Welcome back to the second half of the lesson on simplifying rational expressions. In this portion, we will multiply and divide rational expressions. To multiply rational expressions, the first step is to factor, then state the restrictions, simplify by canceling factors, and write your final answer in factored form. Let's start with this example. So our first step is to factor. We're going to take out a 2 out of 2x minus 8, and we have 2 times x minus 4. When we multiply fractions, we multiply the numerators together. So I'm just going to have one big division bar, and I'm going to factor the trinomial x squared plus 5x plus 4 into x plus 4, x plus 1. Now the denominator, x squared minus 16, that's a difference of squares. So I will have x minus 4, x plus 4. Now the trinomial, x squared plus 8x plus 16, that is a perfect square trinomial. That is x plus 4 times x plus 4. Now I have the numerator and the denominator completely factored. I'm going to state the restrictions. The restrictions are the values that cause the denominator to be 0. If x equals 4, the whole denominator is 0 and the expression is undefined. So x cannot equal 4, and x cannot equal negative 4. If x equals negative 4, the denominator is 0 and the whole expression is undefined. Now I'm going to cancel. I have a factor of x minus 4 in the numerator and denominator that cancels. And I have a factor of x plus 4 in the numerator and denominator that cancels. So it turns out that my factors, x plus 4 times x plus 4, from the perfect square trinomial don't cancel. And I am left with 2 times the factor x plus 1 over x plus 4 quantity squared. I leave my final answer in factored form. Here's a second example. To multiply, we factor both numerators. So I'm going to factor x squared plus x minus 6. That factors to x plus 3, x minus 2. Then I factor the difference of squares, and I'm simply multiplying my numerators together. So this is all one product in the numerator. X plus 5, x minus 5. In the denominator, I have this factor of x minus 5. I'm going to write that over here. That'll make it a little tidier when I cancel. And then I have x squared plus 4x plus 3. Well, that's going to factor to x plus 3, x plus 1. Now I'm going to state my restrictions. From this factor, x cannot equal negative 3. From this factor, x cannot equal negative 1. And from this factor, x cannot equal 5. So those are my restrictions. Then I will cancel. The factor x plus 3 cancels. The factors x minus 5 cancel. And I have x minus 2 times x plus 5 over x plus 1, and I have my restrictions. Now we're going to divide rational expressions. Remember that when you divide, you multiply by the reciprocal of the expression after the division sign. I'm going to start with this 2 minus x and factor out a negative 1. So then it is x minus 2. In the denominator, I have a perfect square trinomial. This is x plus 1 times x plus 1. Now I'm dividing by the numerator. I want factors of 10 with a difference of 5, and I want the bigger factor to be positive. Factors of 10 with a difference of 3. I want the bigger factor to be positive, so it's x plus 5 times x minus 2. Then the denominator is a difference of squares, that is x plus 1, x minus 1. Now we're going to look at our restrictions. This tells me that x cannot be negative 1. Again, x cannot be negative 1, x cannot be negative 1, and x cannot be positive 1. Now I'm going to handle the division sign. When you divide, I'm going to multiply by the reciprocal. So I have my negative 1, x minus 2, and when I multiply, I'm multiplying all the factors in the numerators together. The reciprocal of the rational expression after the division sign means that the difference of squares, x plus 1, x minus 1, comes to the numerator. Then in the denominator I have my x plus 1 quantity squared. I'll keep that expanded. And the x plus 5, x minus 2 comes to the denominator. Now I have additional restrictions because x cannot equal negative 5 and x cannot equal 2. Any factors that show up in the denominator, we have to be concerned about the restrictions. So I'm going to add to my restrictions. I'll list them all here. X cannot equal negative 1. X cannot equal positive 1. X cannot equal negative 5. And x cannot equal positive 2. These are my restrictions. Then I'm going to cancel factors. I can cancel a factor of x plus 1. And I can cancel a factor of x minus 2. And I'm left with negative 1 times x minus 1 over x plus 1, x plus 5. And we'll leave our answer in factored form. One more example. We start by factoring. X squared plus 5x plus 4, we want factors of 4 that sum to 5. That is x plus 4, x plus 1. Then we want to factor x squared plus x minus 12. We want factors of 12 with a difference of 1. And we want the bigger factor to be positive, so that's going to be x plus 4, x minus 3. Then I'm dividing by, in the numerator I have a difference of squares, so that's x plus 1, x minus 1. In the denominator I take out a common factor of 2x, and I have x minus 3. Now I'm going to handle the division, and that is I'm going to multiply by the reciprocal of this rational expression after the division sign. So I will write it all as one big rational expression, x plus 4, x plus 1, 2x, x minus 3. In the denominator, I have x plus 4, x minus 3, and then the factors from my difference of squares, x plus 1, x minus 1. Okay, let's state our restrictions. X cannot equal -4, and x cannot equal 3. X cannot equal 0, because if x is 0, this whole denominator is 0, and then our expression is undefined, so x cannot equal 0, and we already have that x cannot equal 3. Now, after we take the reciprocal of the expression after the division sign, we have a factor here, x plus 1 in the denominator, and a factor x minus 1. So that tells us that x cannot equal -1, x cannot equal +1. Those are all the restrictions. Then we will cancel. The x plus 4's cancel. X plus 1 cancels. And we have a factor of x minus 3 in the numerator and denominator. So this whole big expression simplifies to 2x over x minus 1 with the restrictions that x cannot be -4, 3, 0, -1, or 1. Okay, that concludes the lesson on multiplying and dividing rational expressions.